Good morning students, welcome to Sri Guru online classes. In the last lecture we discussed the numericals from NCERT textbook. Today I am going to solve previous year question papers. In the last year they asked the sum of the numericals from this dual nature of matter and radiations. Today we will discuss one by one from 2014 to 2020. Okay. The many times they ask the numericals from dual nature as well as atoms as well as nuclei. In the modern physics definitely they are going to ask one numericals. They may ask from atoms and nuclei or they are going to ask from dual nature. If they ask 5 marks question from dual nature of matter and radiations, definitely they are going to ask the numericals from atoms or nuclei. If they ask 5 marks question from nuclei, definitely they are going to ask from dual nature or atoms. Like that they are going to ask the numericals. The many times they ask like these questions, instead of this threshold frequency they are going to ask the kinetic energy, or some of the work function also they are going to ask from this question only. Okay. What are the given? You should write first. What are the given in that question? Before going to solve the question, what are they given? First one is frequency, that is nu, which is equal to 7.21 into 10 to the power 14 hertz, or frequency we can also call as 1 by second also, or better you remember hertz only. Why I am writing 1 by second means per second, why I am writing means it is going to cancel in the while solving, it is going to cancel. Okay, listen here. The light of frequency is this much on a photo metal surface. The photoelectrons with a maximum speed of, speed means velocity, v, which is equal to how much? 6.0 into 10 to the power 5 meter per second. The velocity unit is meter per second. This much of speed, the photoelectrons with a maximum speed are ejected from the surface. From this photometal surface, the ejection of electrons takes place about this much of speed. What is the threshold frequency? We should find nu naught. We should find nu naught. Then again they mention h is equal to Planck's constants, that is 6.625 into 10 raised to minus 34 joule second. This is about given values. Okay. Now, which formula we should use? Okay, before going to solve the numericals, we should know how to solve the numericals. Basically we know that what is the Einstein expression. We know that from Einstein expression or Einstein photoelectric equation, Einstein's equation, what is that? Half m velocity maximum square, which is equal to work function, or you write energy h nu minus phi naught, or you can also write energy is equal to work function plus kinetic energy also. We know that what is work function means. Work function is equal to h nu minus h nu naught, and this is half m velocity maximum square. Now what is the common here? Half m velocity maximum square, which is equal to h is common, nu minus nu naught. Now just take h this side. What happens? M velocity maximum square whole divided by this is 2 as it is, and this is h is going to multiply. Now nu minus nu naught. Now just to convert yourself, what you want to solve, frequency. What type of frequency? Threshold frequency, below which there is no emission of electrons takes place. Just to take this threshold frequency this side, negative becomes positive, and this whole terms take that side. What happens? Threshold frequency nu naught, which is equal to nu as it is, this whole terms come this side, means this becomes negative, m velocity maximum square by 2 into h. This is the expression. We should substitute the given values. Listen here. We know the frequency, that is 7.21 into 10 to the power 14 hertz, and we know that mass of electrons, what is the value for mass of electrons? 9.1 into 10 to the power minus 31 kg. This is the mass of electron. And already they mentioned the velocity, that is 6 into 10 to the power of 5, and also they mentioned the h value. Just substitution and calculation processes remains. Up to this is important. Now is very easy. Just substitute and find the final answer. Now threshold frequency nu naught, which is equal to, what is frequency? That is 7.21 into 10 to the power 14 hertz. Don't mention the unit here. Final unit you should write. Now mass is 9.1 into 10 to the power minus 31, and velocity square means 6 into 10 to the power 5 whole square, whole divided by 2 times of Planck's constants, that is 6.625 into 10 raised to minus 34. 6 square means 36. 10 to the power square means 10 to the power 10. Minus 31 plus 10, it is minus 21. Numerator power value is 10 raised to minus 31, and here is 10 to the power 5 square means, that is 10 to the power 10. Now minus 31 plus 10, it becomes minus 21. 10 to the power minus 21 in the numerator. Denominator is minus 34. Minus, if suppose we are considering to numerators, this will come to the numerator, means definitely it becomes plus, that is 10 to the power plus 34. Plus 34 minus 21. 34 minus 21, it is 13. Okay, the power is 13. Now we should convert in terms of 14. Why? Because it is not possible to subtract. First you convert the powers in terms of 14, and you write yourself and calculate yourself what is the multiplication factor and dividing factors. Okay. Calculate yourself. 9.1 into 36. Why? Because 6 square means 36. 36 into 9.1 divided by 13 point something. Why? Because 6.625 into 2, that is 13 point something, divided by that. The final answer is, that is 24.72. The power conversion already be done. That is 34 minus 21. It is nothing but 10 to the power 13. 10 to the power 13. Now it is not possible to subtract. Why? Because here is 10 to the power 14, here is 10 to the power 13. Now frequency nu naught, which is equal to, just to convert yourself, 7.21 into 10 to the power 14, keep as it is, and just to convert this power in terms of 10 to the power 14, just this decimal point shift this side, it becomes 2.472 into 10 to the power 14. Now the powers are same. Now it is possible to subtract. What is the answer means? That is 4.7 something, 4.72 something into 10 to the power 14 hertz. This is the the threshold frequency of that particular metal surface. Below this there is no emission of electrons takes place, there is no ejection of electron from that metal surface. In the sum of the year, they also ask the work function. In this question, up to this is our answer. But in the sum of the year, they ask the work function also, that is work function is equal to h nu naught. Just multiply Planck constant value and threshold frequency, and that is our answer. Okay, this is about the 2017 questions. Note down this. And next come to the 2014 year, also they ask the numericals. That is, the work function of cesium metal is 2.14 electron volt when light of frequency 6 into 10 to the power 14 hertz is incident on the metal surface. Photo emission of electrons occurs. Find. Oh, I think so we already solved this question in the lecture number 6. First time we solved, that is question number 2, I think so. Question number 2 we solved already, that is the year 2014 they asked. Okay, all the questions from NCERT only. If the values are going to vary, okay, just solve the NCERT questions. Definitely that helps to solve the numericals in the particulars. Maybe this year they are going to ask the numericals from the dual nature of matter and radiations. Why? Because from last 3 years they not asked the numericals from dual nature of matter and radiations. These are the numericals enough. Just solve these numericals and practice yourselves many times. Next is, what is first one, momentum, B bit, speed and C bit. The de Broglie wavelength of an electron de Broglie wavelength of an electron with kinetic energy of 120 electron volt given is H is equal to 6.625 into 10 raised to minus 34 joule second. This is our question. This question is also from NCERT textbook only. Why I am solving this type of questions means many times they ask the numericals like this only. Okay. Also they mention the mass of electron. Also they mention mass of electron is equal to 9.1 into 10 raised to minus 31 kg, and the charge of electrons, that is 1 electron volt, which is equal to 1.6 into 10 raised to minus 19 joule. These are the given values. First we find the momentum, then we find the speed, and then we find the de Broglie wavelength. Okay, de Broglie wavelength formula we know, and momentum formula also we know. First one, momentum. How to solve the momentum? From the given values only. What are the given values? H, mass of electrons, and 1 electron volt is equal to 1.6 into 10 raised to minus 19. Momentum is equal to mass into velocity. mass into velocity. Velocity is not mentioned, so it is not possible to use this formula P is equal to mv. This is not possible to solve. Why? Because they mention the mass but they not mention the velocity. It is not possible. Then how to solve the momentum means another formula, that is kinetic energy, which is equal to, or you write EK. EK means kinetic energy. What is the formula for kinetic energy? Half mv square. This is the just conversion, and this is helps to solve the numericals. This idea we should use to solve the numericals. Okay, now just take this to this side. What happens? 2ek, which is equal to mv square. Now multiply m on both sides. What happens? 2mek, which is equal to m into m square v square. I am considering kinetic energy half mv square, and then I am multiplying both sides m. It becomes m square v square. Square root on both sides. Square root on both sides. 2mek, which is equal to square root and squares are get cancelled, so it becomes mv. What is mv? Mass into velocity is nothing but a momentum. Mass into velocity is nothing but a momentum, that is P, which is equal to under root of 2mek. Now we know that the kinetic energy, what is the kinetic energy? The kinetic energy 120 electron volt, and we know that the mass of electrons, that is 9.1 into 10 raised to minus 31 kg. Just substitute the values. Momentum, which is equal to under root of 2 into mass of electrons, that is 9.1 into 10 raised to minus 31, and this energy is 120 electron volt. Just to convert, 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. Why? Because we should convert in terms of SI unit. 120 into 1.6 into 10 raised to minus 19 joule. Now minus 19 minus 31, it becomes minus 50. Square root means it becomes 25. Now multiply these values. 2 into 9.1 into 120 into 1.6. The answer is 5.88 into 10 raised to 5.88 into 10 raised to minus 24. Momentum, mass into velocity. Mass is kg, velocity is meter per second. This is the unit of momentum. Why it becomes 24 means the answer is 58.8 into 10 to the power minus 25. Why? Because here is under root of 10 to the power minus 50, the square root, it becomes 10 to the power minus 50 by 2. Square root means half, it becomes 10 to the power minus 25. Here is our answer is 58.8 into 10 to the power minus 25. I am converting for first decimal point, that is 5.88 into 10 to the power minus 24. Like this we converted. You solve yourself the multiplications and square values, you solve yourself. This is our first bit answer. Now come to the second one. What is the second? The speed. Okay, speed means the ejection of electron from that particular metallic surface, but how much velocity of that ejection of electrons. We can convert that velocity in terms of kinetic energy also. Ek is equal to half mv square. Here is mass into velocity is nothing but a momentum. If suppose I am converting only velocity, I am taking mass this side, means what happens? Okay, Ek becomes half m v square. I am keeping v square that side only. To take this side means 2Ek by m, which is equal to v square. 2Ek by m, which is equal to v squares. Now v becomes v, which is equal to under root of 2Ek by m. Now substitute the values, all the values we know. Under root of 2 into Ek, what is our kinetic energy? 120 electron volt means 1.6 into 10 raised to minus 19. Already they mentioned in the given values. And what is the mass of electrons? That is 9.1 into 10 to the power minus 31. Now minus 31s come to the numerator means it becomes plus 31. Just subtract 31 by 19. 11 means 2. This is 12, around 12. Now multiply 2 into 120, 240 into around 1.5 means nearly about 600 something divided by 9.1. The conversion is 12, 10 to the power 12. What is our answer means? 6.53 into 10 to the power 6 meter per second. 6.53 into 10 to the power, how much? 6 meter per second square. Why? Because this is under root of 10 to the power 12. Under root means by 2. It becomes 10 to the power 6. 10 to the power 6 meter per second. Okay, minus 31, it becomes plus 31, plus 31 minus 19 means 12. Under root of 10 to the power of 12 means 10 to the power 6. Like this, that is the second one. Third one, that is very important. De Broglie wavelength of an electron with kinetic energy this much. De Broglie wavelength lambda is equal to h by p. We know that the p values and also we know that the h value. Just substitute. H value is 6.625 into 10 raised to minus 34 and p is 5.88 into 10 raised to minus 24. Now here is h is joule second and p is kg meter per second. Okay, what is the wavelength? If suppose we are considering this kg meter per second, this second will come to the denominator means per second. Kg meter per second square is nothing but a what happens? The kg meter per second square is nothing but a, listen here, just you converting in the form of joule. Joule is the energy, any type of energy for example I am considering mgh. Here is mass, g is acceleration due to gravity, meter per second square, h is meter. This is completely, suppose I am considering this to the denominator means what happens? What happens? Per second square, like this. We are converting the units in terms of SI unit. The kg meter per second square into meter. This will take to the numerator in terms of wavelength is in terms of meter. That is the conversions. Or you directly write what is the unit of wavelength means meter. Length, that is the meter. Like this we should convert. It becomes, this is the cancellation process. Or if you want to write clearly means what is the division point, that is 1.13 into 10 raised to minus 10 meter. How this meter comes means just yourself the numerator value It is not necessary to solve. Why? Because already we know that. What is the unit of wavelength is meter. How to convert means, that is joule. We can write like this: kg meter per second square into meter. Denominator is and again one more second is there. Denominator what happens? Kg meter per second. If suppose I am considering the second to the denominator is per second. Per second means per second square. This is going to cancel. Already this s is come to the denominators. What is the remaining? That is meter. Like this is the conversion of unit. Okay, this is about the question number 9. Note down. Next one is the very important. This type of numericals also they are going to ask. Okay, note down. The wavelength of light from the spectral emission wavelength of light from the spectral emission line of sodium, spectral emission of line of sodium is how much? 589 nanometer. This is the wavelength of that line emission of sodium. Find the kinetic energy at which they are asking the two ways. Find the kinetic energy at which. For first one is an electron kinetic energy, and second one is a neutron would have the same de Broglie wavelength. Would have the same de Broglie wavelength Okay, this is our question. But there is ask the wavelength of light from the spectral emission line of sodium is 589 nanometer. Find the kinetic energy at which for an electron as well as for a neutron would have the same kinetic energy with respect to particular de Broglie wavelength. This is our question. How to solve the wavelength for a particular electrons and particular neutrons means already we know that the mass of an electrons and mass of an neutrons. Before going to substitute the mass and that particular wavelength, we should know the expression, which expression we should use, and which is going to very easy to solve that kinetic energy of electron as well as kinetic energy of neutrons. Already we know that the de Broglie wavelength expression, that is lambda is equal to h by p, and lambda is equal to h by under root of 2m ek. Ek means kinetic energy, or de Broglie wavelength lambda by under root of 2m ev. in terms of electron volt also. Out of these we can use, this one is very easy to, why? Because the potential and electrons, it is very easy to solve. Or we are going to find the kinetic energy, means just use this one also. Why? Because just substitution of mass of electron and mass of neutron, it is very easy to solve from this expression also. You can use any one of, just that is the conversion. Better, this formula is very easy to solve the numericals. Okay. Now, expression we got. What is our expression? Lambda is equal to h by under root of 2 MEK. What are the things they mentioned? Given values. What are the values they mentioned? One is the wavelength they mentioned. How much? Wavelength lambda, which is equal to 589 nanometer. Nanometer means 589 nano means 10 raised to minus 9 meter. 10 raised to minus 9 meter. And this is about the given values. And we know that already. Mass of electron. What is the value for mass of electron? That is 9.1 into 10 to the power minus 31 kg. Mass of electron is 9.1 into 10 raised to minus 31 kg. What is mass of neutron? Means mass of neutron, which is equal to 1.66 into 10 raised to minus 27 kg. You should remember the mass of electron and mass of neutron. Very important. Keep in your mind. And these are the given values they mentioned. Now they substitute the values in the expression. What is the wavelength formula? Lambda, which is equal to h by under root of 2 MEK. EK is our kinetic energy. Okay. How to find the kinetic energy? That is also very important. Why? Because we are finding the kinetic energy of an electrons, just that is the conversion also. And one more, the value we want means, that is h value, that is h is equal to 6.625 into 10 raised to minus 34 joule second. Okay, now that is the conversion. Square on both sides. Square or squaring on both sides. Squaring on both sides. What happens? Lambda square h square, square and square root get cancels, it remains 2 MEK. Square root and square get cancels, or right ones. Squaring on both sides, this square and square root get cancels. What happens? Lambda square, which is equal to Planck's constant square by 2 MEK. Okay. Now we want EK. Just take this EK this side and send lambda square that side, denominator side. EK becomes, EK is our kinetic energy of electron. First one we are finding the EK becomes s square into 2m into lambda square. This is our expression. By using this expression, you find the kinetic energy of electron as well as kinetic energy of neutrons. Now, first one, A bit. For electron, okay, right, very clearly. First one is for electron. Okay, what is the formula? EK, or just to write, for electron kinetic energy is s square by 2 mass of electron into lambda square. All the values we know, just substitution processes remains. EK becomes s square. What is the h value? that is 6.625 into 10 raised to minus 34 whole square. Denominator is 2 into mass of electron, that is 9.1 into 10 raised to minus 31 kg. And then again is lambda square. Lambda square means 589 into 10 raised to minus 9 whole square. First you solve the power values. Minus 9 square means minus 18, minus 31, that is minus 49, and here is minus 34 means that is 10 raised to minus 68. Here is minus 49, it becomes plus, if we are considering to numerator means plus 49, around 19, around the kinetic energy in terms of 19. Okay, what is the final answer for that means that is the conversion process. Okay, power conversion is okay, just to convert yourself, the final answer is 7.03 into 10 raised to minus 25 joules. 7.03 into 10 raised to minus 25 joules. Why? Because energy in terms of joules. Okay, similarly for neutron also, be bit for neutron, what is the final kinetic energy formula? Lambda square by 2m small n. Small n means for neutron mass, just substitute, Ek becomes 0.625 into 10 raised to minus 34 whole square. Denominator is, that is 2 into mass of neutron is 1.66 into 10 raised to minus 27, and lambda is same for both the electrons and neutrons, 589 into 10 raised to minus 9 whole square. Convert it, what is our final answer means 3.81 into 10 raised to minus 28 joule. 3.81 into 10 raised to minus 28 joules. This is the kinetic energy for that neutrons. Okay, this is about the question. Now come to the next question is, okay, note down. Next question is, calculate the in that first one is momentum, calculate the momentum. B bit is d Broglie wavelength, d Broglie wavelength of the electrons. Okay, they ask the electrons, de Broglie wavelength of the electrons accelerated to a accelerated through a potential difference of accelerated through a potential difference of 56 volt, this much of potential difference, and the given values are, already they mentioned the given values. H is equal to 6.625 into 10 raised to minus 34 joule second. Suppose they are not mentioned also, you should remember these values. Mass of electrons normally we used, that is 9.1 into 10 raised to minus 31 kg, and electron charges is equal to 1.6 into 10 raised to minus 19 in terms of, sorry, they not mention the electron volt upon, they mention the charge in terms of coulomb. Okay, this is the question. Now solve the first momentum, then the de Broglie wavelength for a particular question. How to solve the momentum means mass into velocity. Here velocity is not mentioned in the given values. If suppose first one we should find the momentum means, we can use this formula P is equal to mv, but here they have not mentioned the velocity, that's why it is not possible to solve from this expression. Now we know that already the kinetic energy is equal to the work function for a particular metallic surface, that we can also write like this: half mv square is nothing but EV. EV is electron volt for particular metallic surface, any metallic surface. Here how to solve the momentum means by multiplying m on both sides. That is one of the kinetic energy expression. Just take to this side mv square, which is equal to T EV. Multiplying m on both sides means m square v square, which is equal to 2m EV, and squaring on both sides or square root on both sides. Square root on both sides means square root on both sides. What happens? Square and square root get cancelled, it becomes mv, and here is square root is 2m EV electron volt. Now that is our potential difference V, and E is the charge and M is the mass. We know that the mass of electrons, and E is the charge, and H we know that, and also potential V also we know that V is equal to 56 volt. Now we can substitute the given values, we can substitute those given values. Okay, this becomes momentum, mass into velocity is momentum under root of 2 into mass of electron is 9.1 into 10 raised to minus 31 kg, and E is the charge, that is 1.6 into 10 raised to minus 19, and potential difference is 56. Now multiply 2 into 9.1 into 1.6 into 56 first. Then you convert the powers, that is 50, square root of 50 is minus 25. Now multiply those values and power conversion, ultimately that is around 40.2 into 10 raised to minus 25, or P, which is equal to 4.02 into 10 raised to minus 24. Momentum is mass into velocity, kg meter per second. This is our first one. The second is very important: de Broglie wavelength accelerated through a potential difference, this much. Listen here, we got the momentum. How to solve the wavelength for particular potential difference? There are three formula for de Broglie wavelength, that is Acceleration, already we discussed this formula, the de Broglie wavelength for accelerating potential difference, that is in terms of, that we write, that is h by under root of 2m ek, instead we can write E into V. Electrons means, or you write better here, if you confuse means write here EV means electron volt in terms of, if suppose neutron means you write neutron, if any charge means you write Q. Or instead of this we can use this formula also, lambda is equal to 12.27 under root of V in terms of angstrom. This is also we can use this expression, direct the substitution of potential V. We can use this formula. dBT is de Broglie wavelength, lambda is equal to 12.27 by under root of V in terms of angstrom. What is the potential difference? 56. Just substitute here, 12.27 under root of 56 angstrom. Now root of 56, around 64, root means that is 8, this is nearly about 7, 12.27 divided by 7 is 7 point something, that is nearly about lambda, which is equal to 1.64 angstrom. 1.64 angstrom. This is the final answer. Just you calculate yourself and verify the answer. These are the numericals, the different numericals they are going to ask in the annual examinations. Like this type of numericals they are going to ask, and in the some of the last year previous questions they asked in 1 marks also, they asked in 2 marks, and they asked in 3 marks also. Let us discuss the some of the theory bit questions. Write any 2 types of electron emission. We know that the types of emission of electrons, photoelectric emission, thermoionic emissions, or field emission, or secondary emission. Any 2 you can write. In the year 2014 they asked, and in that year only they asked in the 3 marks also, give the 3 characteristics of photon. Photon rest mass is 0. Photon, you can write the momentum of photons, the formula, and energy of photon E is equal to h nu, or you can write the energy of momentum of photons always in a straight path, and you can write the different characteristics of those photons also. In the 2015 they asked the 3 marks, no, in the 3 marks also not asked. In the 5 marks only they are asked, write Einstein equation of photoelectric effect, give Einstein explanation on photoelectric effect. First you write the equation of photoelectric, that is h nu, which is equal to phi naught plus kinetic energy, or you write kinetic energy half mv square, which is equal to h nu minus h nu naught. Then you give the Einstein explanations. Einstein's explanation already explained in the form of observations, or in the form of 2 ways they explained. One is which is helps to ejection of electron from the metallic surface, and another half of the energy is used to for converting the kinetic energy of those electrons from one point to another point. It is motion up. Okay, in the year 2016 okay, in the 2016 also they asked for 5 marks, Write the experimental observation of photoelectric effect. Experimental observation already we explained. Experimental observation means effect of frequency, effect of intensity of radiation, and effect of potential. Like this, you explain any two experimental observation in detail and mention third experimental observation heading. That is enough for that 5 marks questions. Okay, in the 2017, the year 2017, they asked in the numericals, already we solved that numericals, and again in the 2017 supplementary question paper is there. In that, in the 2 marks they ask what are de Broglie waves, how does the de Broglie wavelength vary with momentum of moving particles. Already we discussed momentum it depends on the mass as well as particular energy. Okay, you explained. And in the 3 marks also they ask the definition, threshold frequency, work function, stopping potential. These are already we discussed. In the year 2018, that is the numericals we solved. The 2018 supplementary they asked write any 3 experimental observation of photoelectric effect. Any experimental observation you write yourself. That is for 3 marks. You explain any one of the experimental observation in detail and mention the remaining 2 experimental observation briefly. Okay, this is about the old or previous year question papers. This concludes this chapters. The remaining numericals from NCERT you solve yourself. Those are the homework for you all. You solve yourself. If you have any doubt, you can ask me anytime. Okay, thank you. All the best for your annual examinations.